Today we're going to learn a second technique for division that's called synthetic division. And we're going to use what we see here, and I want you to look and see if you can figure out how synthetic division works. Synthetic division does the same thing as long division, although it's a bit of a shortcut. And synthetic division doesn't always work, so it's not like you can forget long division. But here is the setup for synthetic division. See if you can figure out what I'm doing. I'm not going to tell you. Okay, there's synthetic division. And in synthetic division, I got the 3x cubed minus 7x squared plus 14x minus 25, remainder 30, in very little work. But where do the numbers come from? How do we do this very little work? First of all, I did the setup in black with the one orange number. Do you see where the black numbers and the one orange number came from? Where did I get the 3, the minus 1, the 0, the 3, and the negative 20? They are the coefficients of what we were dividing. Again, just like long division, the order is very important, and zeros need to be there if something's missing. Okay? And then outside of this sort of black line that I did here, I got a minus 2. Where did the minus 2 come from? Yes. We have an x plus 2, so it looks like we put the opposite sign up here. Okay? And we're going to talk about why it's the opposite sign in a bit. Then there's an arrow here, and the 3 came down. Do you see that that matches up with that 3? How did I get this negative 6? I times the minus 2 times the 3 gave me negative 6. Then the blue, negative 7. How did I get that? Minus 1 plus minus 6 makes minus 7. So synthetic division realized in long division that the number one mistake students made mental math-wise was they screwed up subtracting, especially subtracting negatives. Like, oh my goodness, integers, we're so good at making mistakes when we subtract. So synthetic division said, well, if I change the x plus 2, if I switch the sign to a negative, then we're allowed to add. You notice all of these are adding in the column instead of subtracting. And when you add, you make less mistakes than when you subtract. Adding is a little bit easier than subtracting. And then when I add the negative 1 and the negative 6 together, I get negative 7, which matches up with the blue. Then the blue 14. How did I get the blue 14?
That's negative 7 times negative 2.
The negative 7, well, just the same process as last time, but now it's the negative 7 that gets multiplied by the negative 2 to give me positive 14. Add them again, and I got the purple 14. Can you see how you get the purple negative 28? Once again, you take the negative 2 and multiply by the 14. That gives you the negative 28. Add again, and we got the negative 25. Multiply by the negative 2 again gives us positive 50. Add again. And then this becomes the remainder. This is the constant, this is the x, this is the x squared, this is the x cubed. It's all one down from what we started with. And what synthetic division does is the following. In long division, when you multiply, did you notice that whatever you had first, like that always just went away, right? That always just becomes 0. And as a mathematician, they're like, that's a lot of extra writing to write down. If it always is 0, wouldn't it be so much faster if I did not write that? Then the only thing that comes into effect is, highlighted in yellow, this -1 and that -6 made the 7. This 0 and this negative plus 14 made the 14. This 3 and the -28 make the -25. And this -20 and the +50 make the 30. So synthetic division was a way to streamline this and to make it simpler. If we go to our notes, we can highlight it in our notes. So here it is, synthetic division. And they have an example here. So we can look at the first thing you're going to do if you're dividing by x minus 2, you put it with the opposite sign on the left. If this is written in the correct order, write down the coefficients. If one is missing, we need to add a 0. Bring down that first number, multiply, and then add. Multiply, and then add. Multiply, and then add, and the very last number you get is your remainder. And so from here, you could write your division statement. So synthetic division is going to be a much faster way for us to do division, because you have to write less, and it's more efficient. However, it only works if you're dividing by x plus something or x minus something. If you're dividing by 2x plus something or -x plus something, you still have to use long division. So it only works if we're doing an x plus something or x minus something. So, our setup with synthetic division. We look, very important, is it in the right order? Is anything missing? Very nice of them to write it in the right order. Also very nice of them to not have anything missing. But it's something you always have to check, because if you jump too quick and you write the numbers down in the wrong order, the math result that you get will have no meaning whatsoever. So, I have a -3, a 2, a +3, a -4, and a 5. If I'm dividing by x plus 2, out in front I write a -2. Bring down my first number. Multiply, gives me 6, add. Multiply, -16, add. Multiply, +26, add. And multiply, -44, and add. And I like to do, as a shortcut, I like to put the original question in brackets and say let p of x equals, because your division statement, that's your dq plus r, then you can say p of x equals, our divisor was x plus 2. Our quotient is right here, and our remainder, this is always your remainder right there. Couple of things you can do with your quotient, because now we just have numbers. One of them is, does it make sense that if you took out an x, out of an x to the 4, that your very first one needs to be an x cubed? So I like that, because then I can just start writing x cubed. The 8 will go with an x squared. The -13 with an x, and the +22 is the constant. So that works very well. Otherwise, you have to work backwards and say, this is my remainder, this is my constant, this is my x, this is my x squared, this is my x cubed. And then we still have to write plus our remainder, in this case it's minus 39. And here is our final result. There's our division statement, because this is the divisor, quotient, and the remainder. Your division statement is always divisor times quotient plus remainder. And if you were to actually multiply this out, everything would match up perfectly, except the last number would be 44, because 2 times 22 would give you 44. So you'd have to subtract 39 to make it work perfectly. And what we're going to look at in the second part of today, in 1.2, is setting things up so that we can actually factor perfectly. So questions to circle 8, 9, 11, and